Obesity creates an internal environment of biochemical stress that places immense strain on cellular systems, particularly through the overproduction of reactive oxygen species, ROS. These unstable molecules, generated in excess during states of nutrient overload, cause oxidative damage to DNA, proteins, and lipids. In healthy physiology, such oxidative stress would trigger a robust autophagy response, a protective cellular mechanism designed to clean up the damage, remove dysfunctional mitochondria, and restore balance. However, in the context of chronic obesity, this crucial self-repair system is often blunted, leading to a dangerous cycle of accumulating damage and worsening metabolic dysfunction. Under normal conditions, autophagy acts as a frontline defense against oxidative stress. When cells detect elevated ROS, autophagy is activated to clear out the damaged organelles that are producing them, particularly mitochondria. This specialized form of autophagy, known as mitophagy, is essential for preventing further ROS leakage and halting the spread of oxidative injury. Autophagy also breaks down oxidized proteins and lipids that would otherwise disrupt cellular signaling and structure. This dynamic response is critical not just for short-term survival, but for maintaining long-term cellular health and energy efficiency. In individuals with obesity, however, this defense system is often compromised. Excess fat accumulation overwhelms the cell's regulatory machinery and creates a state of chronic nutrient surplus. The result is persistent mitochondrial dysfunction and elevated ROS levels, but paradoxically, the autophagy pathways that should be mobilized in response become suppressed. The exact reasons for this suppression are multifactorial, ranging from hormonal imbalances like high insulin levels to inflammatory signaling to direct oxidative damage of autophagy-related proteins. The consequences are severe. Instead of resolving stress, cells become progressively more damaged, inflamed, and metabolically rigid. This breakdown of the oxidative stress autophagy feedback loop helps explain why obesity is such a powerful driver of chronic diseases. In the liver, impaired autophagy leads to the buildup of oxidized fats, promoting non-alcoholic steatohepatitis, NASH. In the pancreas, oxidative damage and poor autophagic response contribute to beta cell dysfunction and declining insulin production. In cardiovascular tissues, unchecked ROS fosters atherosclerosis and vascular inflammation. And in the brain, obesity-induced oxidative stress may accelerate neurodegenerative processes, another emerging area of concern. Yet amid this biological crisis, there is a strong potential for intervention. Autophagy is not a fixed trait, but a responsive system that can be reactivated under the right conditions. Practices such as intermittent fasting, calorie modulation, and regular physical activity have consistently shown the ability to reduce oxidative stress and enhance autophagy in metabolic tissues. These interventions improve mitochondrial turnover, reduce intracellular toxin load, and restore redox balance, offering not just symptom relief, but cellular rejuvenation. In experimental models, restoring autophagy in the context of obesity has reversed insulin resistance, improved liver function, and decreased systemic inflammation. Even at the human level, moderate weight loss and increased activity levels have been shown to reduce oxidative stress markers and upregulate genes involved in autophagic processes. Emerging compounds that mimic calorie restriction or stimulate key regulators like AMPK and SIRT1 may further support these effects, though their long-term safety remains under investigation. Still, caution is necessary. While boosting autophagy offers great promise, doing so in a dysregulated metabolic environment must be approached with care. Excessive or misdirected autophagy could potentially harm healthy tissues or exacerbate muscle loss under certain conditions. The goal is not to force the system, but to restore its responsiveness, to help the body regain its ability to recognize and respond to oxidative stress appropriately. Ultimately, the intersection of oxidative stress and autophagy in obesity is one of the clearest examples of how the body's natural defenses can be overwhelmed by modern metabolic challenges. But it also offers a clear and compelling pathway toward recovery. By reducing oxidative load and reviving autophagic function, it may be possible to break the cycle of cellular damage and metabolic decline that characterizes long-term obesity. In this sense, the body holds within it a powerful and adaptable repair system, one that, when reawakened, has the potential to restore health at the cellular core.